Hey, so this is a predator-prey simulation activity. If you are coming to in-person instruction, we'll do this one together, so you don't need to worry about doing that. It is a Flash-based simulation, so if you don't have Flash, you can go ahead and watch this video, and that will get you the data that you need in order to finish the assignment. So animals that eat other animals are predators, and animals that eat their animals are prey. There's a Canadian lynx, and this is a predator of these animals called snowshoe hares. And in this simulation, you will observe the changes in hypothetical populations of lynx and hares over multiple generations. And it's easy to imagine how a predator affects the size of the prey, but watch how the abundance of prey also impacts the number of predators. So you will begin with one lynx in an Arctic meadow. If it does not catch at least 3 hares, it will starve and die. If all the lynx starve, a new one will migrate in from the outside area. So you always have one lynx, even if the one that you just had just died. There will always be at least 3 hares in your meadow. If all the hares get eaten or die of starvation, 3 more will migrate in. So you'll always have 3 hares at a minimum in this simulation. So when a lynx catches at least 3 hares, their squares overlap, it survives and reproduces. So this lynx caught these 3, it landed on them, so it eats them. And because it got to eat, it gets to reproduce and gets to have a baby. So you have one baby for every 3 hares that you catch. A lynx catches only as many hares as it needs to have the maximum number of babies, and it can have up to 3 babies. So it can't catch more than 9 hares because that would exceed the maximum. Lynx that can overlap can starve. If the first lynx catches the hares, they both overlap. So if 2 lynx land on top of each other, then it's just the first one. Hares that escape the lynx all reproduce. The surviving hare population doubles with each generation. So, if this is how many you have and they all live, then you have 12 next time. If the hare population exceeds 360, none will reproduce in the next generation, and half of the current hares starve to death. So 360 is the carrying capacity. This is like our maximum number of hares that we can have, and if we get above that, then they starve to death and die. As the simulation progresses, the lynx will eat all the hares, many lynx will starve, and suddenly the lynx population will crash after the hare population goes down. Go through at least 2 cycles of boom and bust. That's what they call these predator-prey relationships, boom and bust cycles, to be able to see this effect. So I'm going to show you this video here of an actual lynx catching an actual hare. All right, so I don't know if you noticed in that video, but those cats, those lynxes, and those rabbits, they both have like enormous feet to help them run through the snow and get some traction. So here you have your lynx and you have your rabbits. And then when you look at your worksheet, all right, so in your worksheet here, you've hopefully filled in all this top when we looked at the directions at the start. So then here you start with generation 0 and you look for lynx total, lynx starved, lynx babies, hares total, hares caught. So you can get all of that information from here. So lynx total is 1, starved is 1, babies is 0. It starved because it didn't land on any rabbits. So you do 1, starved, no babies, and then hares total is 3, and hares caught is 0. And again, you can get that information here from the simulation. So let's go to the next generation. So the hares caught this time was 2, but that's not enough for the lynx to survive, so it's still 1 starved lynx total. And then remember, when a lynx starves, a new one just like walks in from somewhere else. So 1 lynx starved, no lynx babies. Hares total was 6, but caught was 2. All right, then do a new generation. So here, same information. This time the lynx didn't catch any, so 1, 1, 0, and then 8, 0. 1, 1, 0, and then 8 hares total. None of them were caught. And then remember, the hares double each time. And so I'm gonna stop filling this out. I'm just gonna record the video, and so you can pause the video where you need to get these numbers, and we'll just kind of advance through 30 generations real quick here. So this is generation 3. So if you need to pause the video here to get this data, you can. This is generation 4, generation 5, generation 6. Oh, see how it turned red? That means it caught 3, so that lynx gets to reproduce. And notice that it took a lot of rabbits to support this one lynx and keep it to survive. Generation 7, so that lynx had a baby last time, and now that baby lives too, also because there's a ton of rabbits here. Now imagine doing this activity, but instead of virtually, you cut out all these little rabbits by hand, and then you had these lynx cards. This is how we used to do this with students. So the simulation is kind of nice because it saves you a lot of time. So these lynx both live and they both get to have some babies, but look how many hares you have total. That's a lot. So generation 8, getting kind of crazy in here. Generation 9. Now the hares is going down. And that's because there's lots of lynxes, and in order for those lynxes to survive, they have to eat a lot of those hares, and so you're seeing a decrease. Generation 10, generation 11, generation 12. Now we're killing off those lynxes really fast. Generation 13, everyone is starving to death. Generation 14. Now we're back to there's only 1 lynx again, and we're kind of starting over. So we've got some rabbits, but only 1 lynx. So generation 15, still that lynx didn't make it enough to survive, so it starves to death. Generation 16, this time it lives. Generation 17, 18, 19, 20, 21, 22, 23, back to the start. 24, 25, 26, 27, 28, 29, 30. All right, so this is our last generation, and now we are going to graph this data. All right, so for a graph, this is a predator-prey graph, and these graphs can get a little bit crazy. So what we're going to do is, down at the bottom, this is the easy part. This is where you put the generations that we did. So you're just going to count the number of lines through 30. So 1, 2, 3, 4. All right, and then also label the bottom generations because you always want to label your axes. So on the side over here, this is where we're going to graph the number of hairs on this side. And then you use the other axis on the other side, and we're going to put the number of lynxes over here. And the reason that we do this is these numbers are very different from each other. So if we graph them on the same axis, the lynxes, which never got above what 75 was the largest, the lynxes would be, down here with their data. And then the hares, which got up to 446 was their largest. So they'd be like way up here. And so it's hard to compare data where, they're nowhere near each other on this graph. So this using two different scales, which is confusing. I know we haven't done this before, but using two different scales is how you do predator-prey graphs, so that way it's easier to see the patterns in between them. So number of hairs, the secret, if you remember, to figuring out what to count by is to count the number of lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, sorry, I had to zoom out and I kind of lost count there. So the answer is 40. There are 40 lines. And then if you go up here and you look at hairs total, we're just going to graph hairs total and lynx total. If you go to the hairs total column and kind of scroll down and look for your biggest hairs total, which was 446. Yes, 446. So we're going to take your calculator and you do 446 divided by the number of lines, which is 40, and then whatever this number is, you round up, so to 12. Don't round down. Even though 11.15 is close to 11, you have to round up, otherwise it's not going to fit. So we're going to count by 12s on this scale here. So take a text box, and every line is 12, and you're going to number all the way up the graph this way until you get to the top. All right, once you get that all the way numbered up to the top, then you're going to go ahead and graph the number of hairs. So get a color, and it doesn't really matter what color you use, and then graph. So in generation 0, you had 3. So that would be, I'm going to use a slightly thicker pen so that way the dots show up. So that would be really close to the bottom here, not quite on the 0. Generation 1, we had 6. At generation 2, there were 8. Generation 3, there were 16. Generation 4, there were 32. Generation 5, there were 60. So you go up to 60. Generation 6, there were 116. Generation 7 was 226. Generation 8, 422. Generation 9 was 211 because they went above that max carrying capacity number, and so half of them starved to death. That's why there was a huge decrease there. And then generation 10, 198. And then generation 11, 98. All right, so you're going to keep graphing. I'm not going to do all of them here because I think you get the point. And then just go back and as best you can, you're going to, draw in your line connecting each dot as you go up on the graph. And so, do your best. It's hard to do, on a computer, and that's fine. There's one way up here. All right, just connect them the best you can. on here and then go all the way through, finish all the hairs. Anyway, you get the point. You'll make a graph. Now for the number of lynxes. So with the lynxes, you are going to make a different scale because it's a completely different set. So if you look at your lynxes, you have a max of 75. So if we go to our calculator, you take the biggest number and you divide by your number of lines, then we round that up. That's 1.8, which rounds up to 2. So we're going to count by 2. That's a big difference than counting by 12. This is why we use a different scale. So you're going to go over here and you're going to count by 2s, which should be a lot easier to do on the way up your graph. So go ahead and do that. All right, so you should count all the way up to 80 at the top and pick a different color to do these dots with. And let's do red. All right, so the hard part about this is we're used to like left aligning R, but now you want to right align. So you look over here and kind of slide to the left. It gets easier as you do more of them. But fortunately, the lynx is easier because it stays at 1 for a really long time. So through the first 6 generations, it's at 1. So it's going to be like way down at the bottom of the graph. It stays at 1. And then in generation 7, it goes up to 2. And then generation 8, it goes up to 7. Oop, sorry, 2 would be here. 7 would be this line right here, which is just below the 8. So remember, I'm looking at this number over here, not this number over here. Really, really important. And then it goes up to 27 in generation 9. So 27 would be this line right here, right below the 28. So make sure you're looking at the correct side of the screen. And then, so that was generation 9. And then generation 10, we have 46. So generation 10 to the 46 line. Hard to do. Lots of lines. That's 10, right? All right, right on 46. And so on and so forth. So just make sure that you're looking off to the right here. And then we go up to generation 11 is 61. So that would be between the 60 and the 62. And then same thing, you would just go back and connect them kind of with a thinner line. So just do your best to go ahead and connect those together. And then just make sure you're looking at the right scale. That's, you know, whether you're supposed to be looking at the, ooh, that sucks, whether you're supposed to be looking at the right side of the graph for the scale, or whether you're supposed to be looking at the left side of the graph. But see how it makes it much easier to compare the patterns. Even though this is kind of a crazy graph, I can see that the hare population goes up first, and then in response to that, the lynx population goes up. So we often think about predators influencing prey, but prey numbers change first. Prey goes up, and then the predator goes up. And what you'll see is that then the prey goes down, and the predator goes down, and then they go back up, and they go back up and down and up and down. And then your graph should end up looking, see, yours is going to look different than this. This is what it would look like if we did the same. See how the predator is way down here and the prey is way up here. So we do them on different scales to make it easier to compare the data across to each other. And then once you're done with that, you have the questions here to answer.